Okay, it is lecture number 3 in module number 1. Number conversions. Number conversion.
Good morning, sir.
Good morning.
Sir, we have joined newly to this session, sir.
I didn't get you. What? Tell me again.
We have joined newly to this session, sir.
Okay, welcome to
have-
this. Okay, fine.
Yes, sir.
So happy learning. Okay, fine. So in the last class, let us see what we have seen in the last class. Let us recap. So we studied about the number systems. Okay. The number systems. So what we found that depending upon the number of digits that we use, we can define a number system. Okay. So the number of digits are represented by number of digits are represented by radix, right? What we can call it as radix or base also. We normally call it as base also. Okay. So therefore, according to that one, we have seen, so these are the things. Okay. So different radix, let me paste it here, copy, and then want to paste it here. So this is here somewhere. So this is how we have defined some radix, something like this. Okay. So in the radix or the base 2, we are using only 2 variables. Sorry, 2 digits only, right? So, and a specific name we have given for this one, for the radix or base 2, is binary number system. What is it called? Binary. That means 2. Binary number system, right? That is what we have seen in the last class. And we have also given some name for another thing. So for this one, for example, so base 8, that is also represented as octal number system. Octal number system. So specific names we have given for this one. And another one is also very important one is decimal number systems. Decimal number system. Right? And another essential number system that we have seen here is that hexadecimal number system. Hexadecimal number system. Right? So we have defined that these are the essential number system that we would like to learn more about it. Okay. So binary, octal, decimal, hexadecimal number system. Okay. Now this is what we have seen in the last class. Agreed? Now today what we would like to do is that we would like to convert any number system into decimal. Any number system into decimal. Whatever the radix you give, we want to convert it into decimal. Why? Because decimal number systems are easy to understand for the human beings. Okay, as the humans are able to understand clearly our numbers in the decimal numbers, decimal number system only, not in other number system. Okay, so therefore the topic of discussion today is the first one is conversion of any number system into decimal, decimal number system. So did you get what is the objective of this today's class? We want to convert any number system into decimal. Okay. So by the way, before going to the conversion, another important point let us consider. Okay. If you consider a number n is equal to, how do we define a number n? Defined by, for example, a of n minus 1, a of n minus 2, a of n minus 3, so on and so forth, a of 3, a of 2, a of 1, a of naught. So therefore, we can represent it with the digits as a coefficients. These are the coefficients. This is called a point, and it is possible to write fraction also. A minus 1, a minus 2, a minus 3, a minus 4, so on up to a minus m. A minus m. Right? So therefore, it is all the time, it is very difficult to write this particular thing. Of course, by the way, what we can call it as this is, so this is called integer part. It is called integer part, integer part. What we can call this is, from point to that one, it is fractional part, fractional part. Right. So therefore, this is possible to write in this way also. Okay, therefore, this is available. Therefore, we can see that what is the range of this number? It's the range of, let me call I, for example. I is the one variable I can consider. For example, a0, 1, 2, 3, 4, something like this. It is available from n minus 1, sorry. It is available from less than or equal to minus m2 less than or equal to n minus 1. So it is the positive side is n minus 1, negative side is minus m. Okay, so it is also meaningful way to write n as something like this. N is also, we will write it in this way. Sigma of I is available from minus m to n minus 1 of ai into, okay, so ai I can write it something like this. Okay, but the sum is not there. Okay, it's not, now it's not meaningful, right? This is not meaningful way. So this is what actually, with the help of quotients, we can write the number. Okay, for example, so what does it mean exactly? Let us consider here. Example, for example, 73210, I'm writing in this way as a number n. What is the value of this number? What is the value of this number? The value of this number is 7. Okay, we'll take a big small number. Okay, so therefore 7,000 plus 300 plus 20 plus 1. This is how we have to define the value of this number. Okay, so therefore, whenever you are writing with respect to the digits, these are not coefficient representation. This is called coefficient representation. If you give the values to this one, okay, each and every coefficient must be multiplied its value, its weight. This is called weight. This is called weight, something like this. So 210, for example, 210. Okay, 1. So therefore, these are called weights. So if you want to give the value to a number, the coefficients are multiplied with its weights. How do we get the weights? So normally these are called weights. Weights. How do we get the weight of a particular coefficient? That is depending upon the base number system. So the weight is defined by its radix. Weight is defined by its radix. Okay, so let me write the same n in value form. Okay, let me write n is something like this. Now the n is a, suppose I'll start from here, a0. It is the just after the decimal, the point. It is not a decimal point. We normally call it as, we named something r0 into, so radix r. to the power of 0. So whatever the position, this is the 0th position. 0th position into r to the power of 0, where r stands for radix, plus a1 into r to the power of 1. So the second position is 1, a1, it's a 1, and that's power must be given to the radix, plus a2 into r to the power of 2. Swan up to a n minus 1 into r to the power of n minus 1. Are you agree with me? So just we are giving the values to a number. So whatever the number that we are talking about, we are giving the value something like this. Is dotted here, you put the dot here. And again, we can start for fractional part, a minus 1 r to the power of minus 1 plus a minus 2 r to the power of minus 2. Swan up to plus a minus m r to the power of minus m. Are you agree with me? So this is how we have to give the value to the number. Okay, so therefore, what we normally call it as, this is called coefficient. This is called quotient. This is called weight. This is called weight. So this is called positional weight. So therefore, the radix position, the weight of that number is decided by its position. So this word, let me call this is the 0th position. So sorry, unit position. This is called second position. This is called third position. This is called fourth position, one up to like this. So depending upon the position, we have to know the weight of the particular quotient. Is it, are you agree with me? Okay, now. So therefore, now we can write n values. It's very difficult to write all the time something like this. It is better to write sigma of, because we are summing that we are doing. From where to where we are summing? We are summing from I value is equal to minus m to positive value n minus 1 ai into r to the power of I. So this is how we need to write. This is how we need to write a number in general. This is how we need to write a number in general. Okay. So with this background, I am going to convert something into a decimal number system. Okay. So for example, we write conversion now. Conversion example. Number 1. For example, 1010, something like this, of a base 2. It is a binary number system. I want to convert it into base 10 number system. Okay, now next one, second example. I want to convert 1, 2, or I want to convert it is 213 into 3. It's not 3, it should be 4. 4 into something. 10 base system. Number 3. 7237 of octal into something like decimal. For example, 32BA is multiplied with 16 into the system. So I don't want to go for more details. So I want to do it for only for small things. It is applicable for any other conversion also. So in fact, any number system doesn't matter. So I have considered any radix. It may be 2, it may be 4, it may be 8, it may be 10. Okay, so for the example, this one also, 7329, for example. Okay, so this is, for example, base number system. I want to convert it again into base. What I'll get it. Okay, so this is what the task that I want to do it now. Okay, can we do it now? Okay, so what is the procedure for this? So if you want to convert this binary number system into a decimal number system, just we have to apply the weights of the same number system. Apply the weights of the same number system. What does it mean? So for example, something like this. We have 1 here, we have 0, we have 1, we have 0. These are the questions. What we have to do is that since it does not have any kind of decimal point, okay, so therefore whatever we have here at the last, at the right hand side, this is the first position. Okay, this is the first position. So this is the last position. It is the last position. Okay, so for the first position, what I have to do, 0 is multiplied with its weight, 2 power, its radix is 2, right? 2 power, its position is 0th position, right? Sum with 1 is multiplied with, I'm extremely sorry, but I think better we have to write quotient with the same color. 0 is multiplied with 2 power 0 plus, okay, 1 is multiplied with 2 power 1 position, first, that is the 0th position, this is the 1 position, plus 0 is multiplied with 2 power square plus last one is 1 is multiplied with 2 power 3. We have to get that one. So what is the value is there? That will be radix 10, it will be, what is the value? So to anything power 9. Yeah, anything power 0 is 1, 0 into 1 this is, plus this value is 1 into 2, this value is 0 into 4, right? Plus 1 into 8. So this is the 8 plus 0 plus 2 plus 0. So what is the value of this one? This is 10, base 10. Please remember that. We have to mention its base number system also. Right? Are you agree with, is it understood? So are you getting this, what I'm doing here? Clear? So let us apply the same kind of thing to the another number system also, another number system. For example, the second one we consider here. So this is what let us consider. Okay. So what is the last, what are the digits that I'm talking about? 2, 1, 3. So they have given 4. 4 is radix 4 they have given. So how do we get this binary number system? Sorry, decimal number system. This 3 is multiplied with, what is its radix 4? 4 to the power of, what is its position? 0.
0.
So next one is plus 1 is multiplied with 4 to the power of first position plus, please remember that. So I think it is better to take another number, okay? Otherwise you will confuse. So I want to take it, this is 1, this is 2, for example, this is 1, this is 2, okay? So therefore it's radix 1. So this is what it is, 2. 2 is the value. Next, 1 is multiplied with, sorry, 1 is multiplied with 4 to the power of second position. Agreed? So therefore this is the first 0th position, this is the first position, this is the second position. That's what I'm writing the coefficients. Sorry, I'm writing the weights. So from this one, okay, I will consider it here also, otherwise you will get confused. 1, 2. So what is value then? This value is 3 into 1 plus 8, 16. This is 16. What is the value of this one? What is the value? So 11.
27.
Yeah, it is 27. Therefore, 27 in decimal number system. 27 in decimal number system. I hope you understand the point. Okay, so let us consider another one also. Okay, this one let us consider. Quickly, let us do it. So, okay, 2, 3, 7. So what is the value? So 7 into 8 power 0 plus 3 into 3 into 8 power 1 plus 2 into 8 power square. What is value? Can anybody tell me? It is 7, 24, 64 2 center, 64 to 8, 128. Isn't that right? So therefore, if you add all these things, what is the value? 128, 24, 7. So this becomes 11, 12, 14, 19, 5, 120, 159. So I hope it will be correct, but if it is not possible, you please try to do it. Okay. So right like this, for example, we do 16 also, 2BA. So for example, another example is 2BA. 2BA of 16 radix. I want to convert into decimal. So what I can do it. So by the by, whenever you are writing the hexadecimal number, you observe that this hexadecimal number. So 0 to 9 is we have already known. From A to F we are using, right? So what is the exact number for after 10, after 9? A we are using, only single digit I'm using. Not, suppose if I write 10, it's not a digit, it's a 2 digits actually. So that's the reason why I'm using A is 1 digit. But actual representation of A is, for calculation purpose, A is 10. Okay, B is 11, C is 12, 13, 14, 15. So therefore this is for A, this is for B, this is for C, D, E, F, right? So for the calculation, we have to consider these values. Okay, so therefore 10, A means 10, right? 10 is multiplied with 16 power 0 plus. B stands for 11. 11 is multiplied with 16 power 1 plus. What is the 2? 2 into 16 power square. Okay, so find out this one and it will become 10. That's all. This is how we have to calculate. This is how we have to convert any number into this one. Okay, so by the way, last one we can consider 329, for example. So we can consider, so 3, 3, 2, 9 of base 10 into the same base. Is it the same value, same value only? It has to come. Otherwise, the conversion is wrong. So what is this value? 9 into 10 to the power of 0 plus 2 into 10 to the power of 1 plus 3 into 10 to the power of square. So what is value? 9. What is its value? 20. What is its value? 100, 300. So what is this value then? 329 of base 10. Agreed? Of course, it will be the same only. Conversion of the decimal into decimal is the same only, nothing else in it. So are you getting what I'm saying here? So whatever the radix system that you consider, okay, so if the convention that we consider, it may be a binary, it may be a ternary, it may be an octal, it may be hexadecimal, whatever the number it is, whatever the left hand side it is, whatever the radix is, if you want to convert it into decimal, just use the base weights for the quotients and sum up all the things, you will get binary number system, sorry, decimal number system. Very simple. Clear? I hope you understand. So let us go for a little bit more information. For example, something like this: 101.101. For example, something like this I have written. The fraction part I'm giving. So I want to know what is its value in binary decimal number system. What is its value? Same procedure, but weights will be changing for the fractional part. So what we can see here in this way. So 1 into 2 power 0 at the left hand side. So I'll put it here is a dot here. Plus, first of all, I know that, so I will write it in this one, 0 into 2 power 1 plus 1 into 2 power square. Is it, are you agree with me at the left hand side? Okay, let's go to the right hand side. So 1 is multiplied with 2 power minus 1, right? So that is what the number system that we have seen there. Plus 0 into 2 to the power of minus 2 plus 1 into 2 to the power of minus 3. Okay, so can you find out what is this value? What is the left hand side? So left hand side, this is 1 plus, sorry, this is 1 plus 0 plus 4 point. What is this value? It is 1 by 2, right? 1 by 2 plus 0 plus 1 by 8. Okay, so this value is 5 point. So what is this value? Can anybody guess what is this value? This is first one is actually 0.5 plus 0 plus what is this 1 by 8? 1 by 8 enta there? Chapal naku. 1 by 8.
0.125.
0.125 exactly. 0.125. So what is this value then? 5 point. Right hand side is 0.5 kada. 0 point, sorry. What is value? 6125 in decimal. Agreed? That's it. Very simple concept. So if you learn this one, you'll get some score in your main examination. So they will ask you to convert any number system to decimal.
0.625 no sir.
Yes, that's what 0.5, 0.125. Okay, this is the 5. For example, 0, 0, write it 2, 6.
0.625.
No, I'm sorry. I'm sorry. Yeah. 0.625. That's it. Okay, like this, for example, you take for the sake of practice, we'll take another one. 237.23 of base 8. Okay, so for example, if I write like this, if 4 and raseno, is it a valid number or not? First you check. Is it a valid number or not? So normally we are using the base 4 that we are using, right? Base 4 you are using. So what are the digits that we are allowed to use? 0, 1, 2, 3, that's all, right? But where is the 7 is coming to the picture? 7 in the entire number system, 7 digit is also there. So if the 7 digit is also there, then you say that this is not a valid in the given number system. We should say that it's not a valid, not valid in given number system. That's what we have to remember. So అంతేగాని ఇచ్చినప్పుడు మనకు డైరెక్ట్ కన్వర్ట్ చేయకూడదు. First whether it is valid or not, we need to check by observing the digits existing in the number. Okay, now so if I write like this 237.23 of 8, for example, so now is it a valid number? Yes, it is a valid number because 7 is available in radix 8. So same procedure, let me do it quickly for you. So 7 is multiplied with 8 to the power of 0. From left hand side, I'll put it a dot here. And 3 is multiplied with 8 power 1 plus 2 is multiplied with 8 power square. So what about this side? 2 is multiplied with 8 to the power of minus 1 we have to write, plus 3 into 8 to the power of minus 2. Can you help me? What is this number? Please help me. What about this number? Anyone from the class, please help me in this one. So calculation part is at your side. Please do it. Okay. So the second one is next one is something like this. So what is B? B stands for 11, right? So I'm talking about after decimal point. I'm talking about after this point. Okay. So what is value? B stands for 11 is multiplied with 16 power 0 plus. What about A? A stands for 10. 10 into 16 power 1. This side 2 into 16 power minus 1 plus 11 into 16 power minus 2. That's it. So therefore you have to calculate this one. It will be in the range of 10. So base 10 will be converted. So please try to do it. Everyone from the class has to do this kind of problem. Everyone from the class, please try to evaluate this one. Please try to do this one. So without practice, you are not able to do it in the examination. So very simple. Once you practice to 4 or 5 examples, something like this, you are able to understand how to convert any number system into decimal number system. Okay, so only the integers that we have seen, fractional with integer with fractional part also we have seen, complete number that we have seen. Okay, fine.
Sir,
Yeah, please.
how we are saying whether a number is valid or not?
Yeah, how we should know that? How can we know that whether the number is valid or not? So that is depending upon what is the maximum digit that is available. So example, for example, 72316, something like this. I have given the number. Okay. So observe that if I say that 5 is the radix number system I have given. Okay. So by observing this one, by looking at this number system, I know that it uses only the following digits. What are the following digits? 0, 1, 2, 3, 4. So only these 5 digits only it is accepting in a given number. So if the given number does not have the maximum 4, or it does not have any other number other than this particular 4 digits, we say that that is not a valid number. Okay, so observe this one. First digit is 6. 6 is there in this your given number system? Not there. So therefore 6 is not a valid digit. 1 is a valid digit. 3 is a valid digit. 2 is a valid digit. But 7 is also not a valid digit. Even 1 digit is not a valid. You can say that this is not a valid number in the given number system. It's not a valid in the given number system. That's how we should know that. For example, 321.310. For example, if I say that radix 2, I'm giving. Radix 2 I have given. So what we can say that we have to observe that. So what is the digits that I usually you have to use? 0, 1, only 2 digits only I have to use. That's what the constraint here. So whether 0 and 1 is acceptable, other than 0 and 1, if any digit is available in a given number, it's not a valid. So 0, first one is 0. Yes, it's valid. 1 valid. 3 is available in this given digit? No. So 1 is valid. 2 is not there. 3 is not there. Therefore, total this is actually even 1 digit is not a valid digit means we have to throw it outside. Okay, therefore it's not a valid in the given number system, right? For example, 21010, something like this. I'm using the 3 radix system. Is it a valid number system or not? You see?
Yes, sir, valid, sir.
Yeah, it is a valid. 0, 1, 2 only we have to use. Okay. So other than no number is there. So 0 valid. So therefore it's a valid number system. For example, you consider this. For example, here is a 3 is present here. So these 4 are valid, but 1 is not valid. So the digit 3 is not a valid bit in the given 3 sequence. So therefore, it is all the time, it's not possible to see that 5 digits means 4, I have to write something like this. We should remember that whenever we have a radix r, 5 annan kada. So what is the maximum number, maximum digit that should be there means 5 minus 1 we have to consider. That means this is nothing but 4. So therefore, 4 is the maximum digit that we have to use, right? So that means that if you take a base R system, okay, so what is the maximum number that you can see in your digits R minus 1? This is applicable to any particular number system, okay? So this is how we can understand, we can know that whether the number is valid or not, right? Fine. So I hope you understand how do we convert this one. Okay, even don't worry about it. Don't worry about it. Fractional part is there in your system also, number also. Okay, now, for example, what are the different numbers? What are the different numbers that we can see in decimal part? Okay, so let us see the decimal numbers. So please understand the concept. Oh, what is this happening here? Decimal numbers. So as we know that 0, how many are there? 9 digits, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are the 9 digits, that's all. Okay. So in a decimal number system, we have to use only these 9 digits. If you want to get 10th value, for example, but we do not go for any other digit. Instead, we have to take the 2 digits. Not 1 digit is not sufficient. We have to go for 2 digits because it reaches the maximum digits, right? In that sense, what I have to do is that I have to consider the first one. And put it here. Okay, now we start the sequence again, 0. Okay, now again 1, 1. Okay, something like this. So it's not difficult. It's difficult for me to write all these things. 2, 1, 3, 1, 4, 1, 5. Okay, 1, 6, 1, 7, 1, 8, 1, 9. So therefore, after 1 also, 9 is also completed. Okay, therefore, what I have to do? 110 if I write already is over. Okay, what I have to do then? I have to take the second digit. I have to take the second digit and then I need to start again new sequence 20, 21, 22. That means this is you can see the first positions are all the same. 3, 2, 4, something like this. We can go for it, right? Similarly, if you take a binary number system. Okay, so how many digits are there? We are accepted 0 and 1. Third digit is there, but I want to do it the third one. What will be the third one? So that's depending upon, I have to take this one, 0, 1 here, and I have to place, I can start from 0 and 1, 0, and again 1 I need to place. Once it is completed, then what I have to do? I have to take this number system. 1, 0. Again start with 0. So therefore again start with 0. Next 1, 0, 1. So after completion of this one, again we have gone for another system, another one. So therefore 1, 1, 0, 1, 1, 1. So once it is completed, I have to start from here. So like this, I can form different numbers from this. Again 0, 1, 0, 0, 1, like this. Therefore, I can simply write, you can see, you observe, if a decimal number system is 0 is there, in the binary also 0 only. If decimal is 1, binary is also 1. There is no difference at all. But when the decimal is 2, but binary is nothing but 1 0. Because the nature of the number system is something like that for the binary number. So if it is 3, it should, in the binary number system, it will be 1 1. If it is 4, 1 0 0. It is 5, 1 0 1. It is 6, 1 1 0. It is 7, 1 1 1 1. It is 8 means this, 8 9 means something like it. We have to fill this one. For example, radix 3 number system, let us consider. So can you observe? 0 is the first digit, 1 is the second digit, 2 is the second digit, right? That's all. Now, if you want to get the another sequence, we have to start with 1, 1, 0, something like this. Next one is 1, 1, 1. Next 1, 2. That's it. Now we have to start with 2. Now we have to start with 2. So what is this value? 2 0, 2 1, 2 2. Once it is completed, we have to start with from 1 0 again. We have to start with 1 0, and this is 0. Next 1 0, it is 1, 1 0, it is 2. Once it is completed, I have to go for this one. Okay, 1 1, 0, 1 1, 1, 1 1, 2, something like this. Therefore, what we can say that, so if you want to, for example, let me write like this. If I write logic 0, decimal 0, in radix 3 also the same. Radix 3 same for the decimal. Radix 2, radix 3 is also same for decimal. But here the 3 is not the same, so it is changes to 1 0. 4, it is changes to 1 1, something like this. So that is the 1 point. So the decimal to radix 3. So far we have seen any number systems to decimal మనం చేసాం. ఇప్పుడు ఏం చేస్తాం, మనం డెసిమల్ నుంచి బైనరీ కన్వర్ట్ చేస్తున్నాం, డెసిమల్ నుంచి రాడిక్స్ కన్వర్ట్ చేస్తున్నాం. We are converting the decimal into binary, decimal into radix 3. So like this, we can go for radix 4 also. Radix 4. So any number system, radix 4 or radix 5, or radix 8, something like this. So therefore, what is our conclusion is that whenever we are converting the decimal number system into other system, so this kind of table, it's very difficult to identify. It is very difficult to manage, or it's very difficult to remember. Okay, certain procedure is there. From that procedure, we can whatever the number you give, we can directly convert the decimal number into other radix. That we will see in the next class. Okay, so therefore the conversion of the decimal number system into any radix number system in this approach is not acceptable. It's not at all recommended. So what we have to do, there is a certain procedure is there. From that procedure, we will calculate that one. We will derive that one. Okay, we stop it here today. If you have any doubt, please just send the questions into your modules. Otherwise, please go through it once and twice of this video lecture. Okay, and one more thing is that we have to do the homework. So only 2 questions I'm going to give you. In your textbook soft copy, I have posted in your modules platform. There 1.3 and 1.9. By the way, let me check whether it is correct or not. Yeah. The question number 1.3, the question number 1.9 in exercise problems that we have to do it in exercise problem. So download the soft copy and in our exercise problems, solve 1.3 question and 1.9 question. It's very easy. It's a practice purpose I have given. Okay, please try to do it. Okay, let me check whether this 0.9 is yeah, fine. It's a decimal number system. So any number system to decimal number system, whatever the topic that we have discussed on the topic, the 2 questions I have given, please try to do that one. Okay, we stop it here today. Thank you.